I'm a German car engineer. My motivation to you today is to invite you to work with Indigo, one of the car companies, and I give you a short overview, 6 slides, what we are doing and where we want to collaborate with you. So Indigo is an MIT spin-off. It's not a Taiwan startup. It comes originally from the MIT, and we're building there the next generation of electric vehicle. How we are doing this and what's in the vehicle, I will point out to you. For my background, I have been 20 years with the VW Group. Highlights of my career were building the first hybrid car at VW, 307 miles per gallon. I was part of the first battery projects at VW, and my last career step was transition of Audi from ICEs to EVs. And when I told my daughter what I'm doing, she had told me at a Christmas, "Daddy, you're telling me this 3 years again the same story." And this gave me a very direct feedback that I look maybe for a new challenge. And this is Indigo, and I will bring you a little bit in this. So Indigo is a new class of electric vehicle, and why this is needed comes with the first slide here. Electric delivery and ride-hailing are on the rise, and there are no purpose-built vehicle in this. The background is, as we heard already from Raj, that in Taiwan, 2040, all cars will be electric vehicles. But the story starts earlier. In 2030, all delivery vehicles, ride-hailing vehicles in New York, in California, must be zero emission. And there is no other solution than zero emission vehicles, battery electric vehicles. You know maybe about fuel cell projects. Fuel cells at the moment are going to heavy trucks, class 8. Several OEMs are doing this, but for smaller ride-hailing cars, the only solution we have at the moment is battery electric vehicles. This upcoming trend here, you see the violet line. These light commercial vehicles is a special group. As the Audi guys said in the beginning, we have a rising market of vehicles, especially light vehicles. This is especially the group in the passenger cars, light commercial vehicles. Overall markets worldwide are rising from today's sales, 75 to 80 million cars, and even ride-hailing and a lot of car sharing is happening. In 2035, we have 110 million vehicles. This additional comes by more population and new emerging markets with go as well for individual mobilization. If you are driving with a ride-hailing here in Taiwan, you drive mostly a RAV4. This is a very popular car in the US as well. But for delivery, the problem is people who are doing the last mile delivery, they do not own a new car. They buy a Camry in US. In Germany, they have little delivery trucks, but they are never the first owner of these vehicles. In 2030, all these guys need an electric vehicle. And the only cars which are in the market are in the price range between 40,000 and 80,000 or more US dollars. So no one will go there with a Lucid, which has maybe 130,000 US dollars MSRP, but you definitely don't go with a Model Y and make a package delivery. So there's a real problem, and we will solve this problem with a purpose-built vehicle. The next slide shows exactly the problem or the portfolio of vehicles which are on the market. The fully bottom, you know, is the class 8. You see the Tesla Cybertruck. You see the Nikola, which is as well electric driven, but has shown some weeks ago already a fuel cell. Even a Toyota, which is building fuel cells passenger vehicles, you know, the Mirai, is doing as another project for its truck department a fuel cell vehicle. If you go through this, you see a lot of commercial vehicles. They are more tools. They have nothing to do with the comfort or the price tag of a passenger car. They are really commercial tools. What you need is in, what you don't need is not in there because no one is paying for this. The only thing what you pay for is reliability and cargo space or weight. If you look then to the top, the last one is the green bar. This is a vehicle, it's a Wuling from China. This vehicle is imported by GM to the US to have a smallest, lightest van, electric delivery. This comes very cheap, very easy, and has only an inductive motor. But even this car is too big for delivery and ride-hailing, so we are building this new vehicle, and you already see on the top line, we call it subclass 1. This vehicle has gross weight, so all in, including passengers, of 1,600 kilograms. This is very light. So the lightest cars I have been building were this XL1, the first hybrid. It has exactly this 1,500 pounds. I built an Audi A2 and reduced the weight by factor 3, but these were all like 200 cars built or one-offs. What we are doing here is we are doing mass mobilization, and we are bringing these delivery vehicles and ride-hailing vehicles to the market in 2026, because in 2030 the market has to be turned fully over, so you cannot bring the vehicle in 2030 because then the customer is already dead because he has no vehicle which is purpose-built. So what we are doing here, a little bit like car engineering. On the left side you see a traditional electric vehicle. You have in the front and the rear, you have a radial motor. You see it's radial, it's quite long. And this motor is taking the space, the trunk and the front. The front compartment is called frunk in electric vehicles, but mostly the space is taken. Some cars like the Rivian and the Ford Lightning, they have the classic vehicle architecture, and you can put a lot of things in there, but no one is using this because people are used to have a trunk in the rear of the vehicle. But you see the middle section of the car, maybe 60% is of the vehicle you can use as a passenger, and everything else is taken by technology. These cars are as well quite heavy, as I pointed out. Premium cars are big, heavy, to give a lot of comfort and space. We are going a fully different way. And as I have been responsible as well in my past careers at VW and Audi as well for the vehicle concept, we make the next step to a new electric vehicle architecture. A lot of companies are offering hub motors. Hub motors means that in the rim of the vehicle, in each corner is a motor. So famous cars which are as well cooperating here already with Taiwan through MIH as a deep drive. You have a Yasa which is working with Mercedes or Lamborghini. We have a Schaeffler itself who's doing this for local delivery vehicles. So hub motors are coming to the market, but the problem with hub motors is they are quite heavy, because all the motor, which you see on the left down with the Tesla, is then in the rims. So if the rims are quite heavy, you have an unsprung mass, and this bumpiness goes over then to the vehicle body. You can reduce this when you make the body very heavy, but then you're losing a lot of advantages of the hub motor, because with a hub motor you have electric vehicle, electric drive, direct drive is driven for efficiency, and to add mass to get this this advantage is a paradox. So what we are doing is we have in each of these corners a motor which itself has its suspension. So you have a very smooth ride with a light vehicle. This is the first concept of these. No other vehicle company in the world is doing this. I have seen Indigo when I've done the scouting for Audi and VW worldwide in 2015 in Hong Kong, first pitch, and we weren't able to integrate this in our cars because you need a fully different architecture, high voltage cable, cooling cables, you need more space in the wheelhouses, etc. So this is why we are not a wheel company. We are building a fully new car. This is our secret sauce. We are building a lighter car. This has a lower footprint. We have to transport less material to the factory, and the car itself, while it's lighter, has a lower total cost of ownership while driving this vehicle. So I have done crazy lightweight vehicles and technologies. If you're riding today a Bugatti, I have still 16 parts in this. So I'm a materials engineer and I love lightweight engineering. So I'm quite confident that I can achieve this. And we have some design principles in this vehicle. It's called circular economy. You know this from planes, which are introduced in the market in the 60s, and by renewing them, refurbishing them, they are still using the body cell. The metro in Chicago is built by these concepts, but car engineering, mostly you drive the vehicle 10, 15 years, and then it goes to the steel mill and gets new metal. So what we are doing is we have this longer usability of the car, and the cell of the vehicle lasts longer because the car is not so worn by potholes. We have very smooth roads here in Taiwan, I like it, but if you go to US, I wouldn't call it potholes, it's more glacier cracks. So it's very rough over there, and even California has no freezing times. The roads are covered with potholes. So the technology we are doing here, you see on the left the wheel, and the secret is the blue ring, and this blue ring over there is a special motor technology, so the whole motor is integrated in the rim. To adopt this, we have a quite bigger wheel, and you know this from the BMW i3. It's a 19-inch wheel, so it's bigger, because axial flux is not working, as you've seen in the other examples from the Tesla. With a long motor, you need more diameter. But with the diameter, you get a thin slice, and you can integrate this fully into the rim. We have there quite strong IP portfolio. The company is working since 10 years in the surrounding of Boston, MIT, and Northeastern University. So we're putting more and more innovations there, and we have a big uniqueness there to get these patents, this IP portfolio into the market. We're talking to fleet suppliers and fleet customers. I cannot drop a name, but hopefully we can make an announcement in some weeks. I'm the CTO there. I have done in the past car engine vehicles, and my role is for product and production. And the lower footprint does not come only from less material going into the vehicle. We can introduce as well new production methods. What we are doing, we don't have this like 60 steps to produce a car. You know, a normal car rhythm, every 63 seconds, a new rhythm comes, a new station, you have to put pieces in. We are doing this a little bit different. We have a locker frequency, but only 10 steps. So less footprint, we can go to a normal workshop somewhere. We do not need any paint shop because mostly the parts are pre-covered with corrosion protection. And the outer parts, they can click them off and take them down. If there are cracks on it, they are easily replaced and they come as colored to the vehicle. So we have product and production engineering advantages and IP, and it's all around this vehicle, which enable us to have a very, very light vehicle. So this is a little bit background to build the attention, how the car looks. Maybe some of you have seen this already in the past. On the left down, you see we started with these wheels 10 years ago, and we were not able to integrate a proper steering. So left down, you see here, this is the steering, a rear steering of the car, and the two hub motors are integrated in the front because it's easier to control two wheels which are on one axle. Then you have only take care for the differential between left and right. You know, if you're taking a left turn with a vehicle, the left wheel is slower, the outer circle is driving faster, and this is solved in the past with mechanical differentials since 100 years, and today we do this in the electric way. In the middle, then we have another test platform, and we were already able to do a three-wheeler, so we are still on one axle, but with steering integrated, and this car is quite performant, so we can go to 100 hertz. So this up and down, the shakiness, to eat the potholes in the street, we do not need a sensor to see this. In near real time, the wheel can react to this. I'm not going to show any video here, it's on the web page. And so this gives a very good damping and smooth ride. From this three-wheeler, we decided we are building our own platform, and the platform you see down here. So you know these pictures from sports cars, from Lamborghinis, and my XL1 has as well these pictures. This is a platform, and you see here the front frame, The rear, this is fully different from what a Beetle looks like. The secret sauce is why we took a Beetle. We are car engineers, we like to drive our vehicles in the street. So the rare exception of a Beetle is you have the VIN number on the top head of every vehicle. It's not in the platform. So we will just build a platform like a skateboard and then put the top hat with the VIN number on it. And when the Boston police stops us, they ask for the paper. And we tell them this is a 1973 Beetle. This is the VIN number. These are the papers. And they look to it like, not really, but the papers are correct and they can accept that we are driving in the street. We are not doing this too heavily. We are not going to highways. But we have some crazy hills there in Boston. As you know, it's going up and down. And we can do their nice performance test. The picture right top is in our workshop, and it's not much bigger than this hall here. So it's like Tesla in the early days. Some crazy guys. At the moment, 20+ish people are working on this project, and everyone is there on the ground. So this is a beauty. This is a vehicle from top. The glass, the glazing is tinted because we have some inside innovation there. But to show you this shape, some of you are car guys and you remember the F93, which was the most important research car Mercedes ever did. So in '93, Mercedes made the same shape of the car. And the things you have today in there, the ESC, the ABS, airbags, all this was in this famous research car. And it had as well a very, very progressive seating concept. Means like you have a central driving position in the front, like the Lotus, and in the rear you have a bench where 2 people or 3 people can sit. The advantage is if there's one driver seat in the front, the passengers are sitting half brick behind it, so everyone, even if you're 2.20 meters, can stretch the legs fully. The second advantage is if you're sitting here and the driver is in the middle, you always look into the street. The advantage of this is 1/3 of every person in this room, by average, is motion sick. You don't get motion sick if you see the horizon and see what's coming to you. So for ride-hailing, it's a very comfortable, smooth ride, and very comfortable because you always see where you're going. There are more advantages in the vehicle. This is a little bit older design. What we are showing here is we have this suspension mechanism. The suspension mechanism can pump the vehicle 10 centimeters up and down, high dynamically while driving. You can do the same and press the vehicle down and hook the suspension system when the vehicle is parked. So one of our patents shows you are pitching the vehicle, going down in the rear, going up in the front, and you can ramp in a load, or in this case, a wheelchair. This is a huge advantage. We can do the same with a rolling. So if you're opening the big door on the left side, you can drive in with a wheelchair. The car goes down, and the height of step in is 20 centimeters. Normally, a car, by average, has a ground clearance of minimum 165 millimeters, so 16.5 millimeters, because the average side curb has a height of 16 centimeters, so you have no damage. So we can go really down, drive in, and the last stage is you just take the driver's seat out, and we will the first car for MSRP around 40,000 US dollars, where you have a fully ADA-capable, wheelchair-capable car. This is quite unique and a very good offer because all the retrofitting of a Toyota Sienna, for example, each of these costs 30,000, the retrofitting. Yeah, but we can bring people who have a wheelchair and want to drive their own car. They roll easily in, lock their wheelchair with the proper mechanism, with the state-of-the-art, and they can drive off. This is very good, as I explained, for delivery, or even if you have neighborhood services like a gardener, someone who's cleaning the pool, some handyman, he just rolls in his container out, and he do not have to put everything in the back, load back of this F-150 truck, whatever. This is my last slide. I want to show you again a little bit about the technology and encourage you. Oh, We have a lot of ones here. Maybe this is a little hint. Show you the vehicle once more. This is the rim. This is a classic suspension system you have in every car. And what we are adding here is like this motor. The motor consists of a central rotor. And as I said, we have 2 motors in there. We have 2 stators building the house of the vehicle. This is a very unique patent. It works quite well. We are doing our own machining, so we can do everything in our workshop, from like fixing the magnets, machining the whole mechanism, everything what you see here we can build on our own. So we are quite reactive. If we learn something from the vehicle, we have to change a part, we just do it on our own. The start of production pre-series will be in 2025. Go-to-market will be in 2026. So I hope that this will be in the summer 2026. It's the actual planning. And we have a reach out at the moment with a customer pipeline that we do in 2030, 2031, around 400,000 cars per year. This is only the demand which comes from the delivery. Guys like Uber and Lyft are not in this scenario. We will reach out to Taiwan, as I have done this, Volker Kaese from the Mosaic Lab. I have done with him in the past the startup scouting, and we are as well eager to reach out to the Taiwan supplier base, because 25% of the Tesla parts are still going through Taiwan, so you have a strong ICT background. I would like to invite you to join the movement for a new purpose-built, lighter, smoother ride. Thank you very much.